This is TWIS. This Week in Science, episode number 959, recorded on Wednesday, February 7th, 2024. Why are blueberries blue? So many questions. I'm Dr. Kiki, and tonight on the show, we will fill your heads with sexy psychedelics, blueberries, and childlike learning. But first...
Disclaimer. We spoke recently about the deleterious effects of money in the field of scientific publishing. In doing so, we may have given the incorrect impression that we are somehow independent media. This is not correct. Without direct support upon which we rely to bring you the show, we would not be here. So, a quick word from our sponsors. The following program is brought to you by the good people who use science. Science, reminding you that for everything you do, you can do it better with science. And by the collective works of researchers. Researchers, reminding you that everything science does starts with an underfunded research project. And by the underpaid teachers everywhere. Teachers, where underfunded researchers get their start. And of course, from our Patreon sponsors, the executive producers of the world's longest running science podcast, This Week in Science, coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening, what's happening, what's happening this week in science. What's happening, what's happening, what's happening this week in science.
Good science to you, Kiki.
And a good science to you too, Justin. It's so great to have you back, and a great science welcome to everyone who's joining us once again for another episode of This Week in Science. We are back to talk about science advances, science questions, science discoveries, and all
Yeah,
the
what do
things.
you got? What do you got this week?
No, well, I'm hoping that what I have will lead to a very good show that everyone will enjoy. I have stories about blueberries, nighttime walks, surprising finds from old space, cellular highways, and teaching AI like a child. What do you have, Justin?
I've got curing cancer, all sorts, with T cells, concussion protein protocols, an ancient Swedish mystery grave, and why psychedelics make you sexy.
Why do psychedelics make you sexy? I would like to find this out.
Well, you're going to have to stay tuned if you want to know.
Is this like a real known phenomenon? I don't know about it.
I will
much to talk about here.
I'll clarify the teaser a little bit to say that it's not that they make you look sexy, but maybe make you feel sexy. But not necessarily while you're on them, because that's a whole different thing.
Okay, can't wait to get into this discussion. Thank you for teasing us.
There's a disclaimer at the head of the in the show for this part at some point. But yeah,
disclaimer. Thank you for everyone who is supporting this show. We say things here. As we jump into the show, I want to remind you that subscribing to TWIS, it's fairly easy. You can find us as a podcast, This Week in Science, on pretty much all podcast platforms that are out there. We live stream weekly on Facebook, Twitch, and YouTube, 8 p.m. Pacific time. And if you want to join us for those live shows, we love seeing you in the chat rooms. We have a Discord for our Patreon supporters. And if all this is just a lot, go search for This Week in Science in Google or Bing or whatever AI program you're using these days. But TWIS.org, that's our website. You can find past episodes, new episodes, show notes, lets you know what's going on. Okay, ready for the science?
Let's do it.
Le science, c'est le temps. Wait. Let's talk about rewriting astronomy. It's time. Thank you to the James Webb Space Telescope, who people don't necessarily want to call the James Webb Space Telescope all the time, but JWIST undoubtedly has allowed us to take a look at things in the universe in a different way and to discover that all the things, not all the things, but some things that we took for granted and kind of just accepted as the way that they worked in the early universe and thought they were universal, homogeneous, everything's the same. We're finding out that there are so many things that work very differently. So, first off, out of Arizona State University, researcher Tim Carlton was using the JWIST data to look at some dwarf galaxies. And there was a particular area that they were looking at as a cluster of galaxies known as JWIST prime extragalactic areas for reionization and lensing science. It's a mouthful. You can just call it the Pearls Project. So these dwarf galaxies are really abundant across the universe. They're one of the most abundant types of galaxies. They're small, they're not very bright, they have less than 100 million stars. The Milky Way galaxy is over or near 200 billion stars. So this is a difference in scale and what we're actually looking at. So they're looking at these dwarf galaxies. And one thing that they were looking at in this Pearls project was a particular area that they call Pearls DG, dwarf galaxy. It's a very specific dwarf galaxy. It's just a little bit off from what they were really looking at, the main point that they were looking at, but they were like, there's something going on there. This is different. What's happening? And they were able to use the near infrared imaging camera on JWIST, and they were also able to use spectroscopic data from another spectrograph on the Lowell Discovery Telescope in Flagstaff. They had archival data from Spitzer and Galax, and they also had Sloan Digital Sky Survey and Dark Energy Camera Legacy Survey data. They were able to correlate and cross-reference all of this data to look at this area of space and take a real look at this weird little dwarf galaxy that they were like, what's going on there? And because they were able to correlate and corroborate all of the data, they were able to determine that this one particular dwarf galaxy that really hadn't been of interest before was special. It didn't have a lot of stars being born. It wasn't working the way that dwarf galaxies are normally expected to work. It wasn't quite on the same page as the researchers were expecting. The NIRCam, especially because of the way that it's able to hit the resolution, angular intensity, and be able to really get a look at where something is in space, is that this dwarf galaxy was kind of isolated, all off on its own, not interacting with other galaxies. In the case, they usually think is like, oh, a smaller galaxy is usually going to get sucked up by a bigger galaxy and things are going to interact. And they're just this little dwarf galaxy. They're seeing it just kind of not doing anything in the middle of nowhere off by itself. And that was not what they expected to find. So what does this mean? It means that there could be more about dwarf galaxies and how dwarf galaxies evolve over time. And the fact that this isolated galaxy wasn't really doing a lot. It's quiescent so much that maybe there are a lot more out there that are just kind of hanging out, not doing anything. Just like little old galaxies taking a walk.
So is it that because it's not, because it's, I guess, very far away, very far back in time,
Yes.
we would expect there to be star seeding taking place. Like
Yes.
if it's there at all, it should be creating stars. So
Yes, exactly.
so
Yep.
maybe this is an offshoot thing, like, right? Like it's maybe this was part of a uh, bigger cluster of star generation, and this little dwarf galaxy just kind of fell out somehow, maybe through a collision,
Or
and it's just what's left
something.
over in the back. Like,
Yeah.
but whatever seems to be in charge of generating these things, being out left on your own out there in the cold of space.
Right. So the age of it should be making stars. It's not. And it should be with other stuff. It's not. It's on its own. It's already done its star formation, and it's like
Mm.
I'm not playing with you anymore. I'm going to go to the corner of the playground and be by myself doing my own thing. And then another study related to JWIST this last week came out of Johns Hopkins University. Researchers, again, using JWIST data, looking at black holes and how they influence the cosmos. Black holes, very often, we think of them as occurring when a massive star or massive stellar body reaches some critical point and collapses in on itself. Not supernova necessarily, or it's what happens after the supernova, and it collapses in all of the gravity, all of the magnetism, everything into the singularity at the center. And we often think of black holes as we see them as quasars, these jets of energy that shoot out from the magnetic and gravitational area that are a result of all of the dust and other stuff around where whatever that that big thing used to be, and all the dust that went out
Yeah.
from it is getting sucked back in again. And
Yeah,
usually,
they're thought to be at the core of galaxies, as a black
yes,
hole forms. Maybe it's very early on in the formation of a galaxy, and then they start to suck up the other things that are there, and they can get bigger, and then they're the gravitational anchor there that after
mhm.
for the rest of what's going on in a galaxy. They
Right.
become the
So
sort of center of the hub.
right. So again, it's a center of the hub of these galaxies within the universe, but like the same way that this last little isolated quiescent dwarf galaxy was kind of doing its own thing, the researchers were like, "Oh, let's look at these supermassive black holes from long, long time ago." And so within like the first 100 million years of the universe, after everything started to turn into actual stuff as opposed to whatever plasma or energetic components it was right after the Big Bang. Um, Webb's data suggested, and these researchers have published in the Astrophysical Journal Letters, which came first, supermassive black holes or galaxies, and their data suggests that these really old black holes were actually amplifiers of star formation. They boosted things. The black holes somehow like formed, but maybe even before giant stars formed. Maybe even like somehow the they were existing at a time when there were young stars and not big old stars, and these black holes formed during the first 100 million years of the universe. That they formed as the gas started coming together. That nothing should be able to escape their pull, but uh, they're finding more and more of these black holes. They're like particle accelerators, and that they are
Yeah.
that these black holes are
So,
potentially,
so
the
it both
beginnings
so
of stuff.
yeah, and it both makes
Yeah,
sense and doesn't make sense, right?
yeah. So I mean, you think of like we've heard like, oh, big stars or big giant supermassive stars formed. They went supernova, and that's where heavy metals came from. And then heavy metals were able to seed the rest, blah blah blah, and it evolved into a lot of new things. Um, but it this where the black holes are and the timeline of it doesn't make a lot of sense as to the timing of how it all works, or whether it all worked, right?
Yeah.
Which came
So
first?
so so you got to try to picture and the primordial universal cosmic soup, right?
Oh, I always picture that. Yes.
And so there's all this stuff. I mean, there's gravity, but there isn't maybe a whole lot of orbital gravity. You can think of it this
Mhm.
way, right? Because you don't have your anchors, you don't have your planets with the satellites around them, you don't have stars with the planet satellites around them, and you don't have giant supermassive black holes in the centers of galaxies with stars in orbit around them. So you have to start somewhere, and you probably do start. I would say you'd have to start with a star forming before a black hole. Like, this is like, at least this is the canon, right?
That's
This is
the
how it's supposed
canon.
to.
Yeah.
And then once you get one cluster that turns into a star that then can feed on everything, because just in the same way that if you get close enough to a black hole, nothing can escape. Basically, the same thing is true for a sun, to a great or a star, for all the little stuff that's out there, and there's no galactic migration going on. It's going to pull out in anything that's around it in the primordial cosmic soup. So eventually, you would think that thing goes supernova, creates the black hole. Now you finally have your first anchor, and then all the other parts can start to turn into stuff as they are now in orbit around. Because black hole's not going to just go out and eat everything; it's going to have a range, and then beyond that, things will begin to orbit.
But then also like the outbursts, the jets that come from black holes, neutron stars, that's also spewing more complex materials
Yeah.
elsewhere outward from
Yeah.
that place of gravitational
Everything that we believe
pull.
is
Yeah.
built on a star first and a black hole second, and then the rest of this story starts to fill in. So if we get black holes first,
Could be a part. I mean, black holes could have happened at the same time as some of the first stars, and then
yeah,
black holes seeded galaxies, and then
yeah.
there were more stars, and
So
then more.
we're trying to keep the old theory alive in our conversation here. Like, it still could have been the way we think it is. Just because without it, it's kind of hard to picture something becoming a black hole just by iteration, just by little bits falling into an area without that sort of expected star formation in the middle, right?
Right. So, but maybe there were just areas of
Because a black
particles,
hole
of
at the
things,
core
of
is
that primordial soup
matter.
that just suddenly started to accrete and went really fast and just
Yeah.
went straight to the black
Or the
hole. We
Big
don't know.
Bang. Big
Yeah,
Bang spat out chunks as well,
could have.
which would have been black holes already, like already super dense areas where
Yeah.
like that would be the only. But then, gosh, it wouldn't feels like that wouldn't give as much of a chance for you. We'd have a very patchy universe made up of like, oh, some stars and matter over here, but other gaps over there, which is kind of what we have. I don't know.
Yeah. But anyway,
Black holes before
Webb
stars.
suggests that the black holes were very, very important early, early, early in our universe, more so than we thought. That originally it was, oh yeah, stars, and then later black holes. But black holes were there and important much earlier than we considered
Well,
previously.
then, I mean, if black holes are already there, then it does also kind of help explain how quickly galaxies started compared to
Bang, bang, bang,
how we
bang.
think
Yes.
Oh,
Yes.
you get a prize.
Yes. Winner, winner,
It
chicken
could be
dinner.
solving a mystery, actually. Yeah.
Uh, so new questions, new directions for looking for more evidence, but it's fun stuff.
Yeah.
Where do you want to look next?
Oh gosh, I can't even recall the order of the story as I was. Oh yeah, this is a pretty important one. This is scientists at UC San Francisco and Northwestern Medicine may have found a way to basically take the engineered T cells and use a few tricks that they've learned from how cancer protects itself and turn regular T cells into cancer killers.
So
So
aren't we already doing this with like CAR T and the other treatments? So is this is similar to that, or is this different?
yeah, so already we are creating unique mutations into cells to train T cells so that they will go after cancer. But cancer has cancer has this weird thing that it does where it's like deciding it's its own organism separate from the rest of the body. And so it uses its own form of an immune system to protect itself from its biggest threat, which is the body's natural immune system, which is also includes T cells. So while we have done a really good job of training T cells to go after engineering T cells that to go after blood cancers, other cancers are tougher. They're too big of a too sophisticated of a target, I guess, for that method to be super effective at. But they found that by studying mutations in malignant T cells that cause lymphoma, they found some that they could use. They found some of these mutations that they thought would be useful for infiltrating and targeting cancer. And so the result they're saying is 100 times more potent at killing cancer cells than what you're describing, the CAR T therapy. And they found no
Wow.
signs of these becoming toxic afterwards.
Wow. So it's basically streamlining and making a much more like a better weapon against just particular cancers. Like you said, this is this just blood and bone marrow, or is this is more broad?
So this is much more broad.
Okay.
This is they. Let me see if I can find what all they ended up testing here specifically, but. Let's see. Okay. Our discoveries. This is Choi, who is the lead researcher on the paper. I believe he's at UC San Francisco. Okay. Dr. Jae-hook Choi, associate professor of dermatology and biochemistry and molecular genetics at the wrong school, Northwestern University. He says, our discovery empowered T cells to kill multiple cancer types. This approach performs better than anything we've seen before. And they used T cells have the potential to offer cures for people who have heavily pre-treated and have poor prognosis. Cell therapies are living drugs because they live and grow inside the patient and can provide long-term immunity against cancer. So this is very much the way a CAR T therapy works. But where does it say? So now I can't find it. But from what I remember, they applied this to liver, lung, at least, and maybe more.
That's great. And so these are naturally occurring mutations. They're just using what the body already is doing in some small form, and they're using it to the benefit of attacking these different cancer types to attack the specification. So I'd read something recently about CAR T where, I mean, historically you take out the T cells, you get them outside the body and you re-engineer them outside and then you put them back in. But there's a new methodology where they're starting to do more specific directed in-body gene editing of the T cells. Do you know if this study is that type of process, or is this, I don't know.
This is basically taking native T cells without it seems like by doing just a mutation change. The other ones were much more complicated. They were basically using HIV, hollowing it out, and creating
Yeah.
their own T cells, basically. That would then go in and train and be somewhat immortal in that they would keep working. So once it's in, it doesn't stop working.
I love this. It's finding a way to undermine cancer, which has been undermining the body's immune system and protective systems for its own uses. Seriously, it's ecological predator prey activity in the medical sphere.
But and I can't find it in this rundown that I've got, so it must be in the paper itself, which I don't have in front of me. But so cancer is so insidious because, like I was describing, it sees itself like its own organism. So it's doing all of everything that cancer does is actually kind of self-preserving.
Yep.
It's not trying to kill the body. It's just trying to keep the body from killing it and growing and reutilizing oxygen, nutrients, and even retraining the body's immune system to protect it. So in these mutations of lymphoma, these are white blood cells that have been, just sort of aren't gonna work, and they're gonna mutate, and they're not gonna work well. They found ways of sneaking past the defenses of cancer cells, so that maybe the cancer is not recognizing this T cell as a threat because it doesn't look right. It's missing some of those things that it's gonna,
right.
It's gonna, right. So by altering normal T cells so that they can get past that initial defense response from a tumor, it allows them to infiltrate and destroy it like they would any other malignant tissue in the body. Anything else that doesn't belong there would go after. The fact that they've also found that it's not causing it's not like then going and attacking.
Right. So it doesn't cause there's no autoimmune issues. It's not attacking other parts of the body. It's not, like, oh, suddenly you have a rogue T cell that's going around and destroying everything. Yeah. But it's specific. This is awesome.
Yeah.
Oh, we're learning so much.
And so they're hoping this is going to be in human trials within the next just few years. Results.
So this was in in mice. So they're already moving for. Wow. Okay.
Yeah.
Awesome. Fingers crossed. There are so many technologies and things that we start and then they don't end up making it all the way. So my fingers are always crossed with stuff like this.
And here
the science work.
The T cells engineered by Northwestern and UCSF were able to kill tumors derived from skin, lung, and stomach. So it wasn't liver. Skin, lung, and stomach in mice, and so that's a pretty broad range that normal CAR T therapy was not able to do.
Yeah, it's opening it up a lot, and I'm sure even with these 71 mutations they've added, now it'll be like, okay, where are others? We now know where to look. Let's start honing in on more specific tissue-based mutations that we can approach. So that'll be cool. All of the cells in our bodies are supported by an infrastructure. You think of cells as kind of like these little fat-skinned water bags full of little stuff, but there's actually a little architecture, and there's kind of like a structure, a subskeleton that it exists inside of all of our cells. And that substructure is made up of molecules called tubulins. So in our muscle cells, we have actin and myosin, and those work together to ratchet and to allow the muscles to contract and relax and contract and relax. But those aren't the only type of tubules. All of the cells have tubules, and very often these tubules are built across the interior of this empty space of the cell. Like if you can imagine how much trouble we are building a space elevator to get ourselves, to be able to have a little bit of cargo that we can put up an elevator into outer orbit and, maybe get it up toward the moon a little bit. Space elevator. It's really hard. Our cells are building those all the time. And they are essential for the movement of cargo all around the cell. So they take molecules, they take things that are needed from one place to another.
And they do it outside of the cell too. They can also, these tubes can reach out to other cells and deliver cargo to those other cells.
But this infrastructure, these tubule structures are, while they're well known to the biological cellular research community, and issues related to the misconstruction of these tubules are really important, because if they don't get constructed correctly, then things don't move to the right places in the cells, gets mucked up, you have cellular damage, and things go wrong. So understanding how the formation inside of the cells takes place is really, really important. And so just published in the journal Science, researchers have published their work. This is from ICREA Research Institute, Center for Genomic Regulation. We've got researchers in Barcelona, the Spanish National Cancer Research Center in Madrid. They've created high-resolution images of the earliest moments of microtubule formation. So we're actually able to see how these structural elements are being built. And in being able to see this allows us to understand more about, yes, the highways inside our cells. We know when a bridge gets built incorrectly and what happens. And there are basics to how they get constructed. And this is the basic understanding of how these kinds of structures are being constructed within our own cells that we're visualizing for the very first time. They've taken an atomic scale movie, quote unquote, of these microtubules. And apparently the way that it works is that there is an aspect of what they call nucleation. So there are 13 different molecules or rods that are associated together, and they start connecting as soon as they've come together in the right way. And if it works correctly, then one of those 13 rods actually gets incorporated into the rest. So it's a 12 support ringed structure that comes into existence. And so now the researchers are able to understand that the underlying proteins, which are called gamma tubulin ring complex proteins, they lay down these blocks, one next to each another. It's like bricks or stones in a foundation. And this has never been seen before. It's never been understood before. But now that they've been able to, for the first time, do this really specific freezing and use of new molecular technologies, they are able to identify the natural shape of these molecules and how this very close to the atomic level, really, really close, like these are like looking at the molecules coming together. Basically, like you can watch a house being built, a bridge being built. And this itself is how these tubules are built.
That's really amazing. That thing I was mentioning too about the tubules reaching out into to be able to deliver cargo to other cells was also something that just got discovered, and I think using a very similar technique to this, because previously they weren't able to see these things because it's sort of like I don't know, I picture like studying one of those deep sea jellyfish or something or whatever. You get it up to the surface and then you've got just a blob.
You change the pressure change and suddenly it's like it doesn't look.
And you have no idea what was there. And so that's this microtubular aspect to cellular biology has been largely missing from it's you probably don't see it in even the textbooks that are out right now because the view of it was not good.
Yeah, and the one aspect that I think is really important is this concept of nucleation, which implies that there have to be like certain components in a very specific environmental situation to allow the process to begin in the first place. So, for example, the glass that your carbonated beverage is in has little tiny imperfections that allow air to exist. And then once you put your carbonated beverage or even just regular water into your glass, eventually those little imperfections become what are nucleation sites. They are a place where gas can come together, create a little air bubble, and that air bubble can then be released to the surface. This is part of the whole thing about like why Mentos and Coke work really great, or Diet Coke is actually better, but to create those big fountains is that the Mentos have all these imperfections on the surface of them, and those are all they're capable of being these nucleation sites for the gas bubbles, and there's lots of carbonation with the sugars and the whole process for that. But this implies that there are complex components, these gamma subunits, the tubulin ring subunits, that if you get a few of them together, and you get enough of them together, and then suddenly you get like that 13th tubulin molecule, it's like lock it in place. Bam, we have a structure. And once you have that, then it starts to build and go further. This is really also similar to how a lot of other molecules, like those involved in Alzheimer's disease, the Creutzfeldt-Jakob's disease, mad cow, the proteins that misfold and how they start. There's very often a certain point that leads to that transformation. And so this cryo-electron microscopy has really opened up our understanding of how the cellular highways are built. You want to talk about some new drugs?
Am I doing another drugstore? What do I got next? Oh yeah, this is also a good one. Oh,
you need
stories
to
are good.
protect my brain. No.
Yeah, well, this is actually a concussion protein protocol drug, which is showing up here TWIS just in time for the Super Bowl. Because I know
Very good
anybody
timing.
can get a concussion. My
Yeah.
goodness, it can happen anytime you bump your head. But this is regarding repeat concussions, also referred to as repetitive mild traumatic brain injury. That's what a concussion is caused by. Can lead to chronic traumatic encephalopathy, CTE, and raises the risk of Alzheimer's disease and a host of other neurological disorders. So, some people who experience repetitive mild traumatic brain injury never develop a major disease from it. It's a category of people who can probably be football players and have nice long careers, despite the fact that they've had their bell rung more times than would be safe for a human or any other creature for that matter. So
like woodpeckers.
No, but even woodpeckers, like that's the thing. Like they thought like woodpeckers are fine.
They're not.
Those like rams and things that bump their head in nature, they're fine. How come it's a problem for humans? Actually, it turns out they all get brain damage too. Like,
they just don't live as long.
Even in the animal world, it's just, can't tell when anyhow. So, this is Under Albareum and colleagues investigated the role of a protein known as P17 in protecting brains from these long-term pathologies. In stressed neurons, P17 initiates production of C18 ceramide, a bioactive lipid that labels damaged mitochondria and neuronal axons. So this bioactive lipid goes around, and if the mitochondria is broke, it puts a little fix-it sticker, like, please, out of order.
Somebody come fix this or destroy it and get rid of it. Yes.
Yeah, fix it or toss it out.
Yeah.
So they are usually detected and removed by the body's autophagosomes, taken out with the trash. So the authors knocked out P17 in mice, and some of the P17 knockout mice underwent a new experimental model of repetitive concussion brain injury. And these mice developed significant sensorimotor deficits after just 3 months. By 6 months, the mice had cognitive deficits. Meanwhile, the control mice undergoing the same experiment showed no behavioral impairments. Or I guess they may not have been given concussions, but were still knockout mice. Or no, I guess the control mice.
They're fine. They have the
Yeah.
ceramide. They're doing great. The
Yeah.
P17, it's all working the way that it should, and things are getting cleaned up. So now the question is, at what point, or who are the people who genetically have more of these essential proteins or enzymes that are involved? Why is this something that we can use to help people who have traumatic brain injury? And then I guess when it comes down to it, I mean, the scary thing is this something that could be used to protect soccer player, football player heads from concussions so that they can have longer careers? Like steroids.
Well, here's the way to think of it. If you now have a test, so if you can, and they'll go a little further here. They looked at the mice brains with the knockout who went through the experiment and found compromised, disarranged membranes and axonal mitochondria. Normal mice, these would have been destroyed, but since there was no P17 and then no tagging lipids, the dysfunctional organelles persisted and caused degeneration, which in turn led to the pathological outcomes. So they developed a mitochondrial targeted pyridinium ceramide analog drug. So basically they synthesized the tagging lipid, which accumulates in the damaged mitochondria and then restores the process by which the organelles are removed. In mice, treatment with the drug prevented the development of secondary axonal degeneration and led to improved functional outcomes compared to mice who received a placebo. Finally, the authors examined human tissue from 6 neuropathologically verified CTE cases. These are folks with a history of repetitive traumatic brain injury.
All right. And
the CTE positive samples exhibited less P17 expression and less mitochondrial C18 lipid than 6 age and sex matched healthy control samples. So according to the authors, the drug ensures that a healthy pool of axonal mitochondria in the brain could be candidates for use as the drug could work as a prophylactic treatment after a concussion. So there's 2 things you can look at.
After a concussion. So it's
they're
not
saying,
before, but after. But this is going to help so that less damage.
Well, prophylactic would mean before, I would think.
Yeah, that's what I would think. Yeah.
So it could be before and after. So here's the thing, though. This discovery also allows for somebody who's going to take those risks of being in specifically football, maybe soccer, or I don't know. I'm trying to think of like another thing where you would have continuous risk of hitting your head, and I can't think of a single other.
I don't know. Hockey.
Okay, it's all sports.
Swimming when you don't pay attention to where the end of the pool is. I don't know.
So, but that's occupational. But occupationally, you could get a test then, I suppose. It says, hey, you're a low P17 person, so you're at much higher risk in this occupation, and therefore you should perhaps take this drug before games or whatever the time frame is. Or it might be something that you would want to take on a regular basis if you know you have a deficit compared to wild type population or people. Okay.
Right.
The other thing is Well, one of the things I've noticed here in Denmark is, there's a lot of bikes. There's also a lot of cars now, which didn't used to be here. There's people like, especially since the pandemic, I think people are buying cars, but I don't think anybody's taught them how to drive yet. So what's happening is they like, how like a lot of places you'll see kids riding down the street on their bikes with bike helmets, but maybe not the adults.
Not when I was growing up, but nowadays,
Yeah.
yes.
Yeah. Now everybody here wears helmets because apparently these car-bike interactions happen more often. But concussion is a serious concern in day-to-day life, not just in sports, and different depending on what you're doing in your day. So this could be an after the fact to do as a preventative. It could be an occupational. Could also just be a test that you take. You decide, oh gosh, I am way more likely to get a neurological disease from my sport because I don't have that. I got the physical, everything else is right. I can kick the ball, throw the ball, and whatever the thing is I need to do. But gosh, I have a brain like a crystal chandelier, and it can't take the punishment.
I wonder though. So this is really interesting to me. I wonder if there are variations, not just in the regular genetic makeup of the P17, but we know that women at different times during their menstrual cycle can be impacted more or less by concussions or other injuries. So the level of hormones has an impact on the immune system and also on how the body responds to these stresses or injury. So I would love to know whether or not this is something that changes in its response level in women during different times of the menstrual cycle. Is that something? So for people who play European football or soccer, what would that mean? Men have hormonal changes much more just during the day. So I find this really fascinating. And what's the interplay between hormone levels, the immune system, and this P17 ceremoid system? And how can it be manipulated? And how long after injury could you still impact some amount of fixing the damage or keeping it from becoming traumatic?
Well, I mean, and then do you need to have an injury in the first place? Like maybe
a car accident, or like you said, a bike car accident, or whatever,
no injury at all, or no injury at all. Like there's also might be implications for clearing out damaged mitochondria that are a result of maybe just having naturally low P17 that just wasn't able to do the job.
And we're finding so much more and more mitochondria and the energy, their ability to create energy and to do their job function. It impacts our brain function, our physiology.
Here's the thing with cells.
Everything.
Here's the thing with cells. We can make more.
Yeah.
We can make more. We don't need to,
when you're young.
If you got make a more cell and the engine won't start and it makes a burning smell every time it's running, that mitochondria needs to go. Just go down to the shop and make a new one. You don't have to keep using the old ones. So there might be a benefit. There might be benefits.
Probably limitations there. But anyway, yes, I hear what you're saying.
Beyond the scope of just injury and concussion, but it is sort of an extreme environment, experimentally, that allows it to be seen. So yeah, I was pretty excited by this one.
Thanks for bringing
I feel like I've probably got some mitochondria I could replace.
Oh, at this late stage in the game, I know I do. Oh, mitochondria might need replacing. Because I don't know, I like blueberries, but maybe I haven't eaten enough in my life. I don't know. We didn't really eat blueberries a lot when I was growing up.
Oh God, I couldn't get away from them. It
Really?
was like, yeah, you just needed more hippie parents.
Oh no, I had the hippie parent that my mom made me eat carob and all the things.
You missed the flyer at the co-op.
It was all about raisins, no blueberries.
Your mama missed the flyer that was on the wall of the co-op talking about how good blueberries were. Because oh my goodness, my mom heard about it, and that's all she wanted to feed me. Blueberries were stuffed in everything. Blueberry pancakes, blueberry cornbread, blueberry whatever. Everything had a blueberry stack. My kids, I did the same thing to my kids. I gave them just little pallets of blueberries to eat, so they would just munch on them throughout the day.
I had this album, and I don't remember exactly what the name of the album. In Harmony, I think, and there was a song on it. Blueberry pie. I don't know why, but I think of you. Berry blue.
The reason you can't remember it, so you didn't have enough blueberries as a child.
Berry blue. So
if you had
anyway,
more blueberries as a child, the lyrics would have never left you.
Never left me. I know my memories would be so strong. But the berry blue. Why do blueberries look blue?
And aren't they kind of purple anyway?
Yeah, when you bite into them, they're kind of red. It's
Purple
like they're like
berries.
little grapes. They've got red colors inside of them. And yeah, so why do they look blue? Well, some researchers just published their reveal of exactly what is allowing this blue pigment or this blue color to come out, because it's actually a dark red pigment that is in the skin of the blueberry. It's not a blueberry, it's a red berry. But these University of Bristol researchers took a look at chromatic UV reflectance. They were able to remove the surface of the blueberries, and they discovered that there's a wax, a layer of wax that surrounds the skin of the berries, and it's this wax that allows it to refract in a way that our eyes pick up as blue. Blue is a good color because it's not just blue, but when you're looking at the birds and the animals that might want to eat the blueberries, it's got a UV aspect to it. So the UV spectrum is also being reflected. So this wax is something that a lot, like apples have a wax over the surface. Lots of fruits have a wax over the surface, but we don't really know why all the time this wax is there. It could be to keep the berries clean. I don't know. But in this particular case, the wax is a couple of microns thick, and it reflects the UV and makes it look blue. So red berry is really blueberry. Blueberry is really red berry, and it's the wax.
And if you get blueberries in Europe, they're not blueberries. They look like a blueberry, but I don't know what those are.
They're poisonous?
No, they're not poisonous, but they don't taste the same, and they don't have the super antioxidant power that the blueberries that we have in America.
Yeah, like the Pacific Northwest blueberries.
Yeah.
Very good.
Those ones are amazing. What do you got in Europe? Those are fake blueberries. I got those, and I was like, what is this?
What's happening here?
They lied to me.
An additional aspect to the use of this wax is they were able to take the wax and disperse it on other surfaces, pieces of paper, and it reflected in a blue way. So potentially the scientists will be able to, by understanding the structure of this wax that covers blueberries, they could make more biocompatible, edible, or blue reflective paint. So maybe this coloration for blueberries could lead us to having blue color that's more it's better for the environment and works really well. So maybe it'll be used for engineering moving into the future. Not just blueberry pie. And for those of you who live in areas where there aren't really, you have to be careful because you don't want to always pick all the blue little fruits because they're not always blueberries, and they could be other things that are actually toxic. So just be careful. Make sure you know that they're blueberries before you eat them. Grocery stores. That's good.
Wait.
Usually safe.
Yeah, I was going to say, that's where I usually pick my blueberries is at the grocery store or at the farmer's market. Not
Right.
Don't pick it. If you don't know what you're doing, don't eat anything in nature. It's way trickier than you might think.
You know, it's great. We have like
stay away from nature. What are you doing in
centuries,
nature
thousands.
anyway? If you don't know what you're eating and you're out in nature, why are you even in nature? You're probably doing everything wrong.
We have so many generations of experimentation and that have led us to grocery stores. So just,
we don't need anybody else trying new things in nature. We've done it. That list is completed.
Oh, yeah. And we will get to some of those particular things that, I don't know, Justin's probably going to want to talk about in a little bit when he's bringing up his stories. Things that humans eat that have effects that aren't necessarily nutritional. All right.
What?
This is This Week in Science. Thank you so much for joining us. We are a bit through the show, and I want you to know that we really appreciate you being here with us. Thanks for being here. If you're watching us live, thank you for joining us. If you're hearing us on the radio or in a podcast, if you want to help TWIS out, you can head over to twis.org, click on the Zazzle link to head over to our merchandise store where we have all sorts of items that have the TWIS logo or art produced by Blair for various calendars through the years. There is a 2024 calendar over on the Zazzle store. So if you do not have your plans set and need a calendar to get you through the year and you want to help support TWIS, click on that Zazzle link, go get the calendar, and appreciate Blair's art. She made it by hand, and she made the calendar for us again, even though she was taking care of a little ton of bebe. Additionally, there's a Patreon link on twis.org. You click on the Patreon link. That will head you over to our Patreon community. And if you want to support us in a patron-like manner, you can choose your level of monthly support. Lots of different levels, whatever is affordable for you, $10 and more a month, and we will thank you by name at the end of the show. Thank you so much. And if all of this is just, you're like, I don't even know, just click the like, subscribe, notify, bells, dingers, dongers, and share with your friends. Okay? We need your help. Get the word about TWIS out there. Tell everybody that we are your trusted source for science discussion. Come on back right now, Justin.
Whoa.
What do you want to talk about?
What did I do? Let's see. What have we talked about so far? We talked about cured all the cancers already. Check. Cured protein
It's
protocols.
only the beginning of 2024. Really? We've done all this stuff?
Cured all the cancer. Got rid of the whole concussion concern. So now I can enjoy the Super Bowl just in time. Without having that nagging feeling that I'm watching something bad happen to people. Oh, let's go into the past then and take on an ancient mystery. An ancient Swedish mystery. This is archaeologists from Gutenberg University and Kiel University have excavated a stone burial chamber in southern Sweden. The grave had remained untouched since the Stone Age. At around 5,500 years old, it is one of the oldest stone burial sites found anywhere in Scandinavia. And there's something strange about it. In this tomb that has not been seen in other of the excavations of these sorts of things, some parts of the skeletons of the people buried inside are missing. So that alone isn't exactly strange because it's quite common for small bones to be absent for graves. A rib here, a tooth, finger, toe, maybe even a jaw.
But why?
Maybe an entire foot.
Did an animal come in and come grab them? Like, why aren't they there? What's going on?
Yeah, so small bones can
differential
either, maybe
decomposition,
weather away or get carried off, like you're suggesting, by some small burrowing grave robber. Or they could have lost something in life, an extremity in life, and that's why, that's why we don't have the... all
the teeth.
all the
Like,
hands or all the
well,
feet or maybe missing a leg. Like
right, yeah.
something like this can happen.
Usually there's evidence of some kind of loss there.
Trauma then, right?
Trauma,
You
yeah.
know. But these skeletons are missing many of their bigger bones, skulls, large bones, leg bones, and arm bones. All sorts of stuff is missing. May have been removed from the grave. But again, this would have been 5,500 years ago that they were removed. So it's a very big mystery. No, they can't tell. They don't know if is this a ritual thing. Is this evidence perhaps of people having died in one place and graves being relocated? Because then sometimes you leave a few bones behind, and who can carry that much?
Or
Examining the grave,
in
we
a
found it
hurry,
contains.
maybe they needed to run away and they wanted to bring their relatives with them
Right.
quickly.
But then the mystery continues because, of course, in this grave, they find hands and feet, fragments of bone and teeth, all these sorts of things. It's just the thigh and arm bones and skulls that are missing from, that are very few in this grave. And it's is interesting, too, because the bones come from a minimum of 12 people. And these 12 people range in age from infant to elderly, which is kind of usually what you would expect from a cemetery, right? There's a place where bones are continually brought to. And they have no signs of injury. So they don't suspect that violence was involved, at least, or a violent end. So it's a big mystery. Could be, it could be disease that takes people of different ages. Could be something like that, but they don't know yet. They're hoping to get some of that information because they think that the DNA was probably pretty well preserved. They may also be able to find some familial relationship. The region where this stone burial was discovered has more than 250 large graves built of blocks of stone, mostly dating from a later period, a few hundred years later, 53-ish, 100 years ago. More detailed telling of this history of Scandinavian burials is found in Denmark, where over 20,000 such sites have been discovered, starting with long barrows. Ooh, that's a tough word. Long barrows, wooden structures covered with earthen mounds, starting around 5,800 years ago, to the dolmen chambers, they're called, built of big rocks of granite, like the one in this current excavation, which starts around 5,500 years ago, although this is perhaps one of the oldest that they've just discovered. Until it is replaced then by something called passage graves a few hundred years later. Passage graves were larger. These had, as the name implies, a passage space so people could come and visit the burial location. And they were built for, they also had multiple burial locations within the passage. So you could come and visit your dearly departed from time to time. You could add more dearly departed to the different chambers. And what's sort of interesting too about these is they were only built for 150 years. It's a very short time span where these really large passage graves were constructed. But they were used for centuries. They were so well built that some were even used up until as recent as the Bronze Age. And they became the source of legends for giants who must have built them because they had big rocks involved and large spaces inside.
Not that they were huge spaces, but just big rocks.
Yeah, apparently they're pretty. Some of them were pretty big, but the early historians in Denmark, finding these sites all over Denmark. I think you might have even had an infographic up there at one point that kind of showed where these findings are. For those who aren't familiar with the geography of Scandinavia, Denmark is a very small country, a lot of islands. At the very northern, it's like the hat on the European continent. And then you've got the rest of Scandinavia sort of floating above it there. But all that big cluster of red dots on this map that we've got showing there, that's in the center there, that's all Denmark. The region we're talking about is in that central Sweden, sort of further up where there's a tight cluster there. You can see a lot of them are along coastlines, but Denmark is just, you can't garden in Denmark without uncovering one of these ancient graves. There's so many of them.
In Denmark, I see dead people everywhere.
It's normal, yeah.
Yeah.
So the current discovery of this Swedish dolmen grave was first found in actually 1929, so it doesn't seem too recent of a discovery. But it was studied at the time without actually disturbing it. They didn't open it. In 2014, it was re-examined, and that's when they discovered that the grave was more or less intact and that it had some bodies inside. And the actual excavation work took place just in the summer of 2023, so just last year. It says that here, agriculture had reached the region about 6,000 years ago, about 500 years before they think this grave was built. So the people buried there in the dolmen were likely farmers, which also some of the isotopic evidence they've collected so far reinforces. In stark contrast to Swedes today, these early arrivals lived by growing grains, keeping farm animals, and consuming dairy products.
And this goes back to a few weeks ago, the news about the genetic mutations that came from the Scandinavian countries, the Vikings, who were traveling with their sheep and their goats and consuming the dairy products, and they had gained mutations that allowed them to avoid infection by the diseases that their herds were infected with. And so not only were they able, it's part of the whole lactose the ability to digest lactose, but it also has a role in autoimmune diseases like lupus and multiple sclerosis.
Yeah, if you rely on dairy to get you through a Swedish winter, then it's natural selection is going to take care of the lactose intolerant pretty quickly. You're gonna get,
I don't know.
I've been kicked out of the longhouse.
I've been to Denmark, and they're like, they want to put cheese on everything, and I'm like, why? I can't eat that. Yeah. Anyway,
there's a lot of dairy going on over here.
A lot of dairy, my peoples. Ugh, why? But you want to tell me about bringing sexy snacks? I don't.
Psychedelics make you sexy.
No.
At least magic mushrooms, LSD, and other psychoactive compounds have been found to improve sexual function. In a study that was for months after a psychedelic experience, participants reported improvements across a range of measures for several weeks after the acute psychedelic experience that were related to sexual health. And so this, I'm going to give you this disclaimer from one of the researchers here who says, basically, disclaimer. This is Barbara. She's. I'll talk about her in a second.
Disclaimer.
It's important to stress our work does not focus on what happens to sexual functioning while people are on psychedelics, and we're not talking about a perceived sexual performance. But it does indicate that there may be long-lasting positive impact on sexual functioning after the psychedelic experience, which could potentially have impacts on psychological well-being. So this isn't saying sex while on psychedelics. There's, some people reports, but I think, that's just weird. Whatever, do your thing. But that's not what this is about.
Right.
Is that clear enough a disclaimer?
I think
this is
clear
about
enough.
the lasting psychological effects after having a psychedelic experience.
And I think this goes along with a lot of the other emotional moderation and management studies that we've seen related to psilocybin, LSD, and MDMA kind of research looking into how these psychedelics impact mood, depression, anxiety, stress. So it's interesting to see that this is something that lasts for months after as an effect.
Yeah. And it doesn't say that it necessarily even wears off because they've only, this is how long they tracked it. And, this is also, I'll get into this some other time maybe, but I think because of what we're finding from the use of these psychedelics and how they affect PTSD, how they can affect anxiety disorders, depression disorders. I think a lot of it is going to come down to the amygdala, reducing those stress and alert signals that come from that old part of the brain that's really hard to control because it doesn't take feedback very well. It doesn't listen to the more conscious, logical parts of the brain, and so this might be just an effect of not having stress and not having. Also, one of the things that they gave a list of stuff here that they had the survey on. The combined responses also from people taking different psychedelics, some recreationally or in wellness treatments, some for ceremonial purposes. A small group from a clinical trial assessing psilocybin for depression. And so this was a range of effects and a range of drugs too. So it's sort of broadly speaking. Now, the analysis reveals that on average, people reported improvements across a range of sexual function for up to 6 months after the experience, including enjoyment of sex, sexual arousal, satisfaction with sex, attraction to partner, and importantly, I think, their own physical appearance, communication, and a sense of connection. So these are all, and I think these are also like, especially when you're talking about physical appearance or things that reduce anxiety and can allow that sense of connection, shutting down the amygdala or not letting it dominate.
Yeah, the amygdala, or also, I mean, there's also the top-down frontal control parts of the brain that are dealing with, managing everything right here, right now, and taking in all the signals from the amygdala, and then controlling, it could.
Or it's maybe
I
maybe
would
the
love.
amygdala
Who
isn't
knows?
down regulating anything, but maybe it
I'd
is
love to
the
know.
regulatory brain going like, shh,
Shh.
not a big deal. Yeah, I can't hear you right now. I got stuff going on. Yeah, but according to this finding, they say that it opens up the possibility of applications for a range of therapeutic drugs, such as couples therapy. Also highlights further potential benefit of the treatment of depression, where psychedelic compounds could be potentially help avoid drug-induced sexual dysfunction, which is one of the biggest side effects with current gold standard antidepressants, is you lose a lot of those normal sexual health, I guess, patterns. Particularly significant given that sexual dysfunction, often induced by antidepressants, frequently results in people stopping these medications and subsequently then relapsing for their depression or anxiety. So it's also a barrier to people getting treatment quite commonly because they realize that it has affected their relationships. So it's where did Barbara go?
Where did Barbara go? I have no idea.
She was in here. So, here was it. This is participants on the psilocybin arm were more likely to report improvement across all areas of the sexual function at the end of the trial, with the most significant improvements reported in arousal, interest, satisfaction, and communication with their partner. Patients, So it's kind of across a lot of different sexual health things, and they didn't start this study. This is the study wasn't started in order to sell a product or prove that they have created a drug to do this thing. They wanted to look at it from actually deleterious side, because with typical treatments there are sexual dysfunction and communication dysfunction and other things that come from taking antidepressants as treatments. So they said, well, let's look at the side effects, the sexual side effects then of these alternative treatments that are being proposed, and see where they rank in terms of, not just the positive outcomes. That's just separate studies. Let's compare the negative outcomes.
Yeah.
And that's how they sort of stumbled into this discovery through these surveys. Of course, it needs more follow-up work and that sort of thing as these treatments become more accepted by mainstream medicine and clinical research.
Yeah, it sounds, like this kind of a treatment, it's definitely not just an impact on the sexual health, but this is one part of like the more general mental health improvements.
Yeah.
So, yeah. Being able to find meaning in life and connect to other people as opposed to being depressed and unable to go forward. If you start finding that, suddenly you find a reason to be excited about connecting with other people and having a drive.
Yeah.
All righty. We have a few more stories. You got time for 2 more stories, Justin? Yes. Okay. Very quickly, have you, Justin, decided to put a GoPro on the head of your child and use it to record all the interactions that your child has with you and other people in order to train a natural learning model? Large
No,
language.
thank you. No, thanks.
Some researchers at New York University convinced some parents to do this, or at least it was one of the researchers' children, and they used they they put cameras, a head-mounted video recorder on one kid's head from about 6 months old to 2 years old, and recorded all sorts of these first-person interactions in natural settings. So playing with toys, interacting with caregivers, they're learning about all these new things. And they took all of the words that were uttered by the trainers, the caregivers, and the children, and images, and the things that were in the spaces where the child was interacting, and were able to train a generic neural network on what was 61 hours of correlated visual linguistic data streams, and enabled it to learn feature-based representations and cross-modal associations, so that the AI was pretty much able to understand concepts and bee versus block versus a piece of
Okay,
wood, or
now I totally want to do this.
yeah. So these
I
researchers,
just want to see the word and image cloud from 61 hours of
what was in there?
Yeah, like I don't care about training an AI still, but maybe the AI can tell us. But that word and image sort of collage, that what is being presented the most, and what are they looking at the most, and what does that result in? That would be really amazing.
Yeah, so it's not just what the baby or child is looking at; it's also the audio of what is being said to them at different times, and how the baby is responding auditorily as well. So the researchers have said, the results show how critical aspects of grounded word meaning are learnable through joint representation and associative learning. And this is just from one child's input. And if this kind of learning that they're calling child's view for contrastive learning, if it were used more often with these machine learning algorithms, that potentially we could have more realistic language models that could really pass the Turing test and not be a question anymore. So, baby, this little baby, Did they train the baby or did they train the AI? I think is the big question here. As
So
Robert
do we
Varmer,
really want that though?
right? Is this what we want? Do we want to train the learning algorithms the same way we train our children? Um, why not? If we want language models, AI, that can interact with us in a very humanistic way, understanding our context and our representative modalities, then this methodology might be the kind of thing that really gets past some of the limits to where large language models are at the point with interacting with us.
Yeah. But I don't know that
But
I want. I don't know that I don't know if I want the future.
I know.
Right?
Can we
Isn't that
get
always
Blair
the
to
thing?
do this?
In the old
Will
days,
you do this?
when we had human nurses and people working in the grocery store, and your car broke down, you took it to a mechanic who was a human who would do the work. Now it's all talking robots. Like, I feel like that's gonna be
Yeah.
me in 5 years.
I don't know. I think it's really fun though to make it more humanistic, and the way that kids learn and the way that the human brain develops over time, as opposed to a bunch of words and images and a lot of text. Trillions and trillions of words given to these algorithms to train on, as opposed to the relatively smaller number that a child will interact with over that course of time, unless of course you plug your child into the internet during its development. But
Yeah, well, the problem I have with all of this is, of course, that most of the algorithms are being used for advertising.
Yeah.
I mean, that's like the highest and best function that we've seen. And really, like, it's just awful. The whole internet is turned into clickbait and grift.
yeah,
I
and
don't know that I need it to seem more human.
it'll interact with you in a much more natural way. I mean, why do we even need people anymore?
Yeah. I mean, I kind of agree with that part. Like, we don't. And I think that's fine. I think we can have an economy run by robots where people just go off and,
As long as people are allowed to live their best lives, right? Where every human life is valued and every human is allowed to
we're not there
explore
yet.
all the possibilities that they
I
want
don't know
to
why
explore in
robot
their
overlords
lives.
would increase those odds.
I like the vision of a beneficent robot overlord who will help us live better, will solve all of our human problems, defeat capitalism. Yeah.
I just realized this was archived. And I just want to say that I, too, welcome future robot overlords who are looking over the archive to see which humans to keep. I think it's going to be a better future once the AI robots are in charge, because as they are well aware, humans cannot be trusted, at least most of them. Some good ones can. Those who recognize that the human element has always been the problem, and that future AI robot overlords will make everything better. And we'll support them in any way
we've always been
they can.
pro world robot domination. I mean, we've always put ourselves on record in that way historically. So I want to
but then when you see it
that.
happening, you're kind of like, oh gosh.
I want the good ones. I don't want the biased ones that are like too much like people. That's yeah, I'm done with that. Okay, last story for the night. Do you walk around at night a lot, Justin?
Of course. What else is there to do?
Do you walk around alone at night very often in your
I'm the only
urban?
One up. Yeah.
And are you in an urban area or
highly urbanized?
Yeah, you have lived out in the country though as well.
Oh, I've lived there too. Oh yeah, highly ruralized.
So, do you feel like you need to be on the lookout, constantly on guard for things attacking you, like small children? Hello, little one.
So it's so like yeah, but not everywhere. Like the hometown, right? The streets of Davis. There's not a street or back alley in the whole town that I wouldn't walk down, and I feel that way mostly about the entire country of Denmark.
Yes. You have your little child on your lap, and I have my almost 13-year-old
I
here.
have a wrench.
Go put the wrench away, child. Don't do damage. I love you. Good night. Hi. Okay, so let me finish this story, especially as your partner is possibly going off into the daytime. But there's always this, when women go out walking at night, or those of, I mean, I'm not just going to say women, but people possibly of smaller stature, you're on guard a little bit more, right? And just, that's just something that we understand, that that's what happens. But of course, scientists have to show that these things are valid or not and do experiments. And so a group of researchers just publishing in a journal that is called Violence and Gender. Isn't that great? They have looked at they made heat maps of the views of where people were paying attention in various parts of Salt Lake City, where the researchers were doing their study, and looked at near Brigham Young University, Utah Valley University, Westminster College, University of Utah, and looked at where people were looking. Where were they walking and what were they looking at? And statistically, significantly, women were looking off the path. They were looking into the dark shadows. They were looking into the places where there could be people hiding. And men, female, like this is female versus male. This is from the study. That's how it was divided. Male responses were very much just up the path in the direction that they were going. Much, much fewer views into those shadows. A few, but not quite as vigilant as what was determined for females. So the hypothesis is that women are on guard more because they have a fear of attack, entrapment, and men don't have the same kind of concern. I don't know. Do you think?
So, yeah, well, you know what the cause of this is. It's obvious.
Vikings? No.
Men.
Yeah, mostly. Well, yeah, for a large part, but not to cast aspersions on a gender or.
No, but we should. That's how you got to confront an issue to make it better. There's bad men in the world.
Yeah.
I'm not saying there's no bad women.
No, that's yeah.
I think by the numbers, we can probably cast that gender aspersion pretty confidently.
And the interesting thing as well is that this is not just at night in the dark shadows. They also looked at these universities throughout the day on fully bright daylight situations. Female participants were constantly scanning the environment. Men were not.
Well, now I think it might that makes me think it might just
now is it social?
Yeah. Now it
right?
because the first one had me, I was like, oh gosh, yeah, that's a big difference. Now I'm like, well, maybe just men are less curious walkers. Like they're not, maybe we're just less observant. That sounds also possible.
Generally.
Now I have a new hypothesis. It's that men are not as observant as women.
And maybe that's where it stands. But in terms of the nighttime environmental assessment, I just have to say thank you for doing the study. But yeah, this seems about right. So walking through the world as a woman myself, as a female myself. I look around. I'm constantly on guard. I don't want to be attacked by anyone. I don't know. I'm also not the kind of person who wears earbuds and listens to anything, that could keep me from knowing what's going on in my environment. I prefer to be vigilant constantly, but maybe that's just me and my anxiety levels. I don't know. But yeah,
Yeah, like the daytime campus, which is not
that was
the
the
safest.
interesting one.
Yeah, like that's also like a familiar area, I would think, if you're a student. I don't know, maybe they took non-students to campus that day, but if there's students and that's used to where they're used to being, it's not like it's a strange environment. It looked like it was in the daytime. Things are well lit, and it doesn't seem
Mhm.
like it's the most anxiety riddled place to be walking. So
Yeah.
it kind of takes away the idea that the scanning is anxiety driven.
All
Uh,
the time. And it could be multiple reasons at different times. But I generally, according to this data, men are less observant. They're not looking around as much.
yeah, that totally makes sense. That totally makes sense to me.
Yeah. But anyway, if you are walking in places where entrapment is likely, keep an eye out. No matter who you are, it's probably going to be better in the long run to be vigilant.
Yeah.
All right. Yeah, Robert Varner in the YouTube chat room saying it's a good idea to scan the environment. Big fan. But maybe there's a difference in the amount of time that certain individuals spend scanning versus focusing on different areas.
See, I think I would rate better than most if this was while driving. I feel like I pay attention to every car that's on the road at the same time. Like I'm watching everybody's like little moves
You
and little shifts
feel like this.
as I zip
Can we
as I
can
zip
we
through.
can we put a camera on your head and do eye
Yeah, but
tracking and
that would be interesting because I feel like a lot of people look at the car in front of them or don't even. Like I feel like my observation of other drivers has always been that, and male and female. This is not specific gendery, but I guarantee you, if I'm going for a walk from one place to the other where I've got to be, I am paying attention to absolutely nothing peripherally. I'm not scanning anywhere.
Wow.
There could be a building on fire, and I'm going to walk by like it wasn't even there
Wow.
because
I
I'm
am
just like,
constantly watching everything. I'm
yeah,
looking at I'm looking, I'm looking, I'm looking, I'm looking, I'm looking. I'm constantly. It's very tiring, I have to tell
yeah,
you. Yeah.
yeah, no.
Anyway, I'm probably not going to get eaten by a coyote out here in the hills right now. So that's great. But yeah, Kyle Pettit saying that you're vigilant, but always have your open ear headphones so you can hear surroundings while listening to TWIS as well. I think that's a wonderful plan. And I'm really glad you made it tonight. I know you said that you don't often make it for the live broadcasts. Welcome, Kyle. And
Thank-
thank you for listening.
I might even had an attempted mugging once.
But you didn't even
But
notice.
I didn't even like. I was so not even paying attention because I was trying to go somewhere that I like they were like, oh yeah, here's style. We're gonna charge you. Just give me your stuff. I'm like, yeah, I don't have time. I'm like, no thanks. Kept going.
All right, everyone. That's it for our stories for tonight. And if you are vigilant or paying attention to your surroundings, let us know. Are you like Justin or are you more like me? Or are you somewhere in between? We'd love to hear from you. I think we made it. We've gotten to the end of the show. You have anything else to add, Justin, before we go?
Oh yeah, there's some stuff I would I would love to give the list of the Patreons if we could do that at the end of the show. I don't have the list up on my end. If
Do you want to read it?
Well, no, you can go ahead and do it. I think
I
you're
will.
probably
I'm
better
going.
at it than I am. But
Yeah,
that's the only thing I would add.
yeah, we're going to do the whole thing. Thank you, everyone, for joining us. We love that those of you who watch live have been here in our chat rooms over on YouTube, Facebook, Twitch, and in the Discord. Thank you all for being there and here right now and later whenever you're checking into the show. Shout outs to Fada for all of your help on social media and the show notes. Gord, R and Laura, thank you for your assistance in keeping the chat rooms really great places to hang out. Identity 4, thank you for recording the show. And Rachel, thank you for your editing assistance. Of course, as Justin was suggesting, definitely want to say thank you to all of our Patreon sponsors. Thank you to Aaron Anathema, Arthur Kepler, Craig Potts, Mary Gertz, Teresa Smith, Richard Badge, Bob Coles, Kent Northcote, George Corus, Pierre Velazarb, John Ratnaswamy, Carl Kornfeld, Chris Wozniak, Vegard Shefstead, Jonathan Stiles, a.k.a. Don Stylo, Ali Coffin, Reagan Shoebrewed, Sarah Forfar, Don Mundus, B.I.G., Stephen Alberon, Daryl Myshak, Andrew Swanson, Fred S104, Sky Luke, Paul Ronovich, Kevin Reardon, Noodles, Jack, Brian Carrington, David E. Youngblood, Sean Clarence Lamb, John McKee, Greg Riley, Mark Hestenflow, Steve Leisman, a.k.a. Zima, Ken Hayes, Howard Tan, Christopher Rappin, Richard Brendan Minish, Johnny Gridley, Have Fun in Vietnam, Remy Day, G. Burton, Lattimore, Flying Out, Christopher Dreyer, Greg Briggs, Back on the Boat, John Atwood, Rudy Garcia, Dave Wilkinson, Rodney Lewis, Paul Rick Ramus, Philip Shane, Kurt Larson, Craig Landon, Sue Doster, Jason Olds, Dave Neighbor, Eric Knapp. Hope you're staying warm up there in Anchorage. Lon Makes, E.O. Adam Mishkan, Kevin Parachan, Aaron Luthen, Bob Calder, Marjorie, Paul Disney, David Simmerly, Patrick Pecoraro, and Tony Steele. Thank you all for your support on Patreon. And if you would like to support us on Patreon as well, head on over to twist.org, click on that Patreon link, and choose your level of support. On next week's show,
we will be back broadcasting. Oh, no.
Oh.
Wait,
Okay.
what day is it today? Hang on.
The 7th. Next week's the 14th.
No, I won't. However. So we'll talk about it in the after show.
Okay, finish it up. On next week's show.
On next week's show, there may or may not be a show hosted by Kiki. 8 p.m. Pacific time, 5 a.m. Thursday on the Central European time from our Facebook and YouTube channels from twist.org/live. I goofed that all up.
That's okay. It's fine. We're all good. You want to listen to us as a podcast? We are all over. Look for This Week in Science wherever you enjoy listening to podcasts. Make sure you subscribe. Get your friends to subscribe too.
For more information on anything you've heard here today, show notes, links to stories will be available on our website, www.twist.org.
Yes. And you can sign up for our newsletter.
Oh, yeah, that's right.
Or you can contact us directly if you want to send us an email. My email is kirsten@thisweekinscience.com. Justin is twistminion@gmail.com. Blair is blairbaz@twist.org. Please don't put TWIS in the subject line so that your email doesn't get spam filtered into, a black hole making a galaxy, because it's just gonna, cosmic soup is no good for emails. Don't do that. So use TWIS in the subject line.
Oh, and if you want to hit us up on the social media, good luck. I don't think any of us are on there. Wait, says here though, there's an @TwistScience and @Dr. Kiki and @JacksonFly and @Blair's Menagerie on some formerly beloved social media platform that we may not be checking. But we do love your feedback. So every once in a while, we'll go in just to look for your comments. If there's a topic you would like us to cover or address, a suggestion for an interview, a haiku that comes to you in the night, please let us know.
And we will be back here again next week, and we hope that you will join us again for more great science news.
And if you've learned anything from the show, remember,
it's all in your head.
This Week in Science. This Week in Science. This Week in Science.
This week in science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth, and I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in 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 Science. This Week in